would talk about variants of carbon. So he was very angry, Kepler. But anyway, here was Van Top. Very, very important to remember. Van Top was one of the greatest physical chemists that in fact, was the founders of the subject of physical chemistry, Van Top. And chemistry became three-dimensional for the first time because of Van Top, because of the tridimensional valence. Till then, chemistry was plain on the sheet of the paper. So chemistry, single, double, and triple bonds, without knowing what the bonds were. They didn't know what those lines meant. They were not drawing lines based on the idea of valence for a very, very long time. Then, of course, a very important name in chemistry, Michael Faraday. I hope you all know Michael Faraday. His story, many of you know, I will not repeat it. Started as an assistant, a bookbinder. All he did was, this is very important for chemistry because we are celebrating International Year. He went to listen to 3 lectures in chemistry by Humphrey Davy in London. After listening to 3 lectures, he wrote down the notes and bound them up as a book and went back and gave this book as a present to Humphrey Davy. Sir, I have brought you a book, bound your book of 3 lectures. Humphrey Davy has got a big, he was a very powerful man. He said, oh, wonderful, very good, you have a very good memory or something, he sent away. After a few weeks later, he went back again, this young boy, do you think we can give me a job in your lab? He said, yeah, sure, why don't you come and clean the classroom? He was a cleaner in the laboratory. He was like many of the cleaners you find in the chemistry department. And that's what happened. Of course, he went on observing Humphrey Davy doing experiments. Then slowly started helping him doing experiments. Then he went around with him all over Europe, just helping him to do experiments. Then started doing experiments in Rome during nights. Then very soon, his experiments are much better than Humphrey Davy. And he started, Humphrey Davy made him superintendent of the laboratory, but no longer laboratory cleaner. And then, of course, he slowly started publishing his own papers. Faraday's record in science, don't ever forget, the chemist Faraday, his record in science cannot be put in by anybody in the future. Nobody, of course, was there in the past. In the future also, in the next several centuries to come, nobody can beat the record of Faraday, who wrote 451 papers. Single-handed, no government grant, no research scholars, nothing, one man. And more than that, see what he did was amazing. He discovered so many new things. Unfortunately, he lived in the 19th century, you see, there was no Nobel Prize. But Lord Rutherford said, if only he lived in the 20th century, he would have got 7 or 6 Nobel Prizes. There's no doubt. I have counted, I think we could have given him easily 5 Nobel Prizes, definitely. Why? Laws of electrolysis, Nobel Prize. Discovery of benzene, another Nobel Prize. Magnetism, paramagnetism, diamagnetism, they are easily discovered. Faraday, Nobel Prize. Discovery of electricity, another Nobel Prize. Of course, you know the famous story when he discovered electricity, you know the joke, right? The finance minister, Mr. Ram Mukherjee of London at that time, Ram Mukherjee was not there, the finance minister of London, went and asked him, Mr. Faraday, what is the use of this discovery? You remember the famous answer, Mr. Minister, someday you will tax it. And exactly what happened. This is Michael Faraday, a great chemist, he was a professor of chemistry, and many people make a mistake, say, oh, it was past chemistry. No, he was a chemist who did physics, that's a different thing. But again, this is what my lecture is all about. How did Faraday do electrolysis? There was no electrons at that time. Electron was discovered in 1897, but he did electrolysis in 1834, 1833. I don't know, because 1833 is a very interesting year. You know, his book, he used to write every day, meticulously in a book, every experiment he did neatly. All this you can see in London, very well preserved. If you see 1833, which I have seen directly myself, 1833, 24th December, experiments on electrolysis, he describes. 1833, December 26th, he works on heterogeneous catalysis using platinum. Only 25th December was missing, because it was Christmas Day, one day only missing. He was an unbelievable man, he was a great man, and of course, he always used to give lectures for 1 hour, that's very important to remember. He used to come to children like you and talk about to children and others. I hope you don't mind my calling you children, because I'm old enough to call you. And he would come and take a standard candle. A standard candle, of course in India you got too many sizes. In the old days when I was young, candle means only one type of size was there. That standard candle burns exactly 1 hour. So he would come and light up the candle and start his lecture. And he would end the lecture, except the candle would go off. And he would say, nobody has the right to impose himself on an audience for more than 1 hour. So if any of your professors gives a special class more than 1 hour, don't ever attend a lecture more than 1 hour, please. What did Faraday do? I already told you. Now, you see, some people say, when did modern chemistry really start? One way of looking at it is the number of elements. You see, in the first century, we knew only 7 elements. 16th century, 10 elements. Lavoisier's table in 18th century had only 23 elements. Today, of course, we have 114 elements, of course, which include all the noble gases, the artificial ones, and of course, I put C.N.R.'s figure. Glenn C.N.R. was my teacher, so I want to put his figure because he was the one who made plutonium. I hope you all know what plutonium is. And these are all the artificial elements of C.N.R. and others. We know 114. One way, therefore, looking at it is modern chemistry started in the 20th century because that's when all the elements. Of course, chemical synthesis, on the other hand, for which chemistry is known, again, historically, the first compound was made by man in the year 1828 by Frederick Wohler, and of course, he made a very simple compound, urea, very useful compound, but it's very simple. But of course, as time went on, people started making more and more complex molecules. Look at that, 140 years later, in 1968, vitamin B12 by Woodward and Schmoser, people started making very, very complex compounds with asymmetric centers and so on. But the first compound, however, was made by Wohler in Germany in 1828. Well, now I want to quickly go to the earliest chemists. The first part of the lecture is history. You have to know. First, Emil Fischer got the first Nobel Prize in organic chemistry. Second was Grignard, the Grignard reaction. And the greatest, one of the greatest organic chemists, whom I consider to be the trinity of modern organic chemists, Will Stacker. He got the Nobel Prize in 1915. Of course, you all know the story of Emil Fischer. Emil Fischer could crystallize any compound, particularly sugar. I'm not joking. You take a sugar, dissolve it in water, get back the crystal again. Well, I'll give you a prize. Anybody who can do it in 1 hour. I can tell you nobody will do it. Impossible. So, but this guy could crystallize any sugar or anything, because very important part of his experimental technique was that beard. The beard was very important. See, they said he never shaved his beard. The beard had all the nuclei of all kinds of organic compounds. So what he would do is he would go to the bigger resolution to shave the beard. Okay. That is the Fischer. And the Stacker, among the 3 great organic chemists of the 20th century, Stacker, Robinson, and Woodward, they say, belong to a trinity, and he is the one who wrote the structure of cyclooctet tetrane. How did they write? Even now it amazes me. There was no idea of chemical bond. Nobody knew about electrons properly, electrons and chemical bond. He wrote the correct structure of cyclooctet tetrane. I know, after he knew the structure of benzene, you would expect him to write a structure similar to benzene, but he didn't do that. He wrote a correct structure, and it always amazes me how we need such things. And the early physical chemist, Van Top is for those who want to know history. The first Nobel laureate in chemistry in the world is Van Top. 1901, first Nobel Prize with a physical chemist. What did Van Top do? Anybody can tell me? Van Top isopore. You do know that? You don't know? Okay, let me tell you what was it. You remember rate of a reaction. dC by dt is equal to Kc to the power of n. N is the order of the reaction, C is the concentration. First man wrote that equation. How did he do that? When you look at early 20th century, he wrote that thing. He wrote minus free energy is equal to orbital K. How did he do that? Amazing. We use that orbital K is equal to minus delta G free energy in equilibrium. He did that all in the early 20th century and late 19th century. And of course, I know Oxford, all the modern or physical chemists of the early 20th century were trained by Oxford. A number of things he did. Oxford writing, Oxford diffusion law. Oxford, he did a lot of work on law of mass action. What did Oxford writing? Large things grow at the cost of small things, right? Big particles, big droplets grow at the cost of small droplets. So that is true of society. In society, rich people grow at the cost of poor people. That is also Oxford writing. Okay. The other 2 great physical chemists, Nernst, who gave the third law of thermodynamics, Arrhenius discovered the electronic theory of dissociation, again before the discovery of the electron, around the same time. These are all the amazing discoveries. The famous early inorganic chemist, first Nobel Prize, Ramsay, who discovered noble gases, Moissan. I'm very unhappy about his Nobel Prize, 1906. He could have got it later, but unfortunately they gave him 1906. I'll tell you why I'm unhappy about it. Of course, coordination chemistry, Werner's theory, he got it 1913. Ramsay, of course, is very important for me because I was associated with the Indian Institute of Science, Bangalore, for many years, and was the director of the institute also for a long time. You know, when the Indian Institute of Science was to be created, many people went to the British government when they were ruling us. Let us have a research institute in India. And the Tatas offered the money. And Lord Curzon, sitting in Delhi, said, no, nothing, India doesn't require any research institute. He would agree. Then when they went on pressing him, he said, okay, I will ask the Royal Society to decide whether there should be a research institute in India or not. And the Royal Society appointed a committee of which the president, the chairman was Ramsay. And Ramsay's committee recommended that there should be an Indian Society. And so we in the Indian Society are very always remember Ramsay. And the first director of Indian Society was a student, Travers, with whom we discovered all the noble gases. Actually, poor Travers should have shared the Nobel Prize. You see, Travers was a lecturer, Ramsay was the professor. The professor got the Nobel Prize, the lecturer went home eating, I don't know what. But nowadays it doesn't happen. You have a lecturer with whom I will make a discovery, he will share the Nobel Prize with me. But in my case, the problem doesn't arise because I won't get it. But in their case, they're very unfortunate. But Moisson's story is very important. 1906 he got it. Why do you think I'm happy about it? It is because of this. Mendeleev did the periodic table. This crazy Russian chap, I don't know how he thought of periodicity. And he could have got his Nobel Prize in 1906 because he died in 1907. You see, but Moissan could have got later. But you see, Moissan, they got it for fluorine with a Frenchman. You know, those Indians, Russians, they're all in one group. Even now we are like that. Nobody thinks of Indians and Russians and Serbians and Slovenians. They will always think of Americans and Frenchmen and Germans. So poor Mendeleev didn't get a Nobel Prize in 1906. That's why. But he is another man. I hope you all know this. I'm sure you don't know. Because I don't know very few, I don't know Indians, very Indian, good Indian chemists who understand the periodic table. In fact, very few really properly appreciate the periodic table. Understand and use it. I'm one of the big users of periodic table. Actually, I room, my table, I even when talking to students, many times I look at it, even today, every week at least once, maybe because there are many ideas in it, which you have to have the feeling for it to use it properly. It's a very fantastic table. And this is in fact, according to me, the greatest table that man has created, and its use they will never cease. That is the periodic table. And of course, now I'm coming to the end of this part of the talk, modern chemistry, when did it start? According to me, modern chemistry started when we decided to put two electrons between two atoms and call it a bond. Until chemical bond was understood, we didn't have modern chemistry according to me. Because we were writing lines without meaning, structure without meaning. So this happened in my first paper in 1916. C.N.R. Lewis wrote the first paper on chemical bond. He is my academic grandfather, a graduator. I can tell you, C.N.R. Lewis' paper. Unfortunately, very few people have read it. None of the professors I know have read it. So students, I don't expect you to have read it. You must read 1963. How he thought of those ideas. It's very amazing. He wrote the first paper in chemical bond. Of course, this became very famous because his ideas were made into a better theory by Linus Pauling, who wrote the famous book, Nature of the Chemical Bond, which he dedicated to C.N.R. Lewis later. That is C.N.R. Lewis, very important. I show him his cigar because he used to smoke about 25 to 30 cigars a day. In fact, in Berkeley, University of California, when he was alive, we knew where the chemistry department was because we could smell the cigar. The entire building was stinking of cigar. And he's always smoking cigar. And he was the greatest modern chemist. According to me, if I have to pick one chemist, the greatest mind in chemistry, I would say first would be like C.N.R. Lewis. And then I would put Linus Pauling as number two. C.N.R. Lewis' ideas in chemistry are many, many. and today I'm not going to talk much about it. There is another lecture I gave called the story. People start crying at the end of the day. It's called The Man Who Did Not Get the Prize. In that I have a lot of the place. Today I'm not going to talk much more. But chemistry after the chemical bond, what happened? I remember, I'm a child of that period, you see. I was doing my MSc when I first read Nature of the Chemical Bond in 1951. My God, I said, well, if this kind of chemistry exists, I said, I must do that. I said, you will not believe it. Actually, what happened to me? So I was in Benares. So I wrote to Linus Pauling, dear Professor Pauling, I've read this book, Nature of the Chemical Bond. Will you take me to work with you? I didn't know I was young. I was only 17 years old. I was 18 years old then. I got a nice letter from Linus Pauling. I no longer do molecular structure. However, you can come and work with my student who is doing a small molecule electron diffraction. You can do with him. In fact, I went to work with the student later after my MSc. That is not the point. The point is the structure, as soon as structures could be determined, organic synthesis chain, we knew structure means we knew many things about chemistry. We knew how to make molecules, design molecules, how to make them useful. Number of things happened because of that. And of course, a whole bunch of prizes were given for that. Reaction mechanism became possible because everything became a reality. Chemistry, synthesis, structure and dynamics in chemistry got affected by advent of chemical bond. Of course, then you see, this is what I mean. I just finished my MSc, around doing my MSc, when the structure of alpha. That is exactly when I wrote it. And the real story, it's not a joke. 1951, he got the alpha helix. So when he said, I don't have a